Welcome to the Explainer. Today, we're going to pull back the curtain on the most important piece of software on your computer. It's something you use every single second, probably without even realizing it. It is the silent, invisible boss that makes everything else work.
Okay, so here's our game plan for diving into the powerful world of operating systems. We're going to start with what it is, then get into what it does, where it came from, and finally, what makes modern systems tick. Let's get into it.
So to really get what an OS is all about, let's just start with something you probably do 100 times a day without giving it a second thought.
You know, it feels so simple, right? It's instantaneous, almost like magic. Your idea becomes an action, and the computer it just responds.
I mean, what's actually happening in there? What's translating your simple click into a fully functioning application, or a picture on your screen, or a message sent across the world? The answer, and really the hero of our story today, is the operating system.
And that's the absolute key takeaway right there. The OS is the master translator sitting right between you and the raw physical computer hardware. It's the bridge that makes all communication possible, managing absolutely everything behind the scenes. You know, I love this slide because it perfectly captures the OS's split personality. It has to serve two masters, and they both want different things. For you, the user, it has to be simple, pleasant, intuitive. But for the computer itself, it has to be a ruthlessly efficient manager, making sure every last bit of processing power is used perfectly.
So, to pull off that balancing act, to serve both you and the machine, every modern operating system is built around three core non-negotiable missions.
And this right here, this is basically the OS's entire job description. First, it has to hide all the messy, complicated hardware details from your apps. Second, it has to act as the fair but firm boss for all the computer's resources. And third, it has to give us that friendly look and feel that we all actually interact with.
So that first mission, abstraction, it's just a fantastic concept. The best analogy is driving a car. You use a steering wheel, a gas pedal, a brake. You don't need to know anything about internal combustion engines or gear ratios. The OS does the exact same thing for your software. I mean, think about it for a second. The OS uses this idea of abstraction to create the very concept of a file. Your word processor doesn't need to know how to read specific magnetic sectors on a spinning metal disk. Nope. It just asks the OS to open this file, and the OS handles all the messy details.
And then there's resource management. In this role, the OS is the ultimate traffic cop. It makes sure every single program gets a fair slice of the processor's time and its own protected chunk of memory. Without it, having 10 different apps open at once would just be total chaos.
And finally, we have the mission you see every single day, the user interface. This is the windows, the icons, the menus, the mouse pointer, all the stuff that makes a ridiculously powerful machine approachable and, actually easy to use.
But these amazing ideas didn't just pop out of nowhere. They evolved over decades of really clever problem solving, as computers grew from these simple, room-sized calculators into the complex machines we have in our pockets today.
This timeline really shows that journey, right? I mean, we went from literally flipping physical switches on giant machines to feeding them one single task at a time on punch cards, all the way to this incredible juggling act that happened in the 1960s, which really set the stage for the personal computers we all use today. One of the huge breakthroughs back in the 60s was this idea of multiprogramming. See, programmers realized that when a computer was waiting for something slow, like reading data from a tape, the super expensive CPU was just sitting there doing nothing. Multiprogramming was the genius idea of letting the CPU switch to another job instead of just waiting around. And spooling, that was another super clever trick from that same era. Instead of your program getting stuck waiting for a clunky, slow printer to finish, the OS would basically say, hey, just give that print job to me, I'll save it to this super fast disk, and you can get back to work immediately. And then came time sharing. And this was the critical innovation that made computers truly interactive for the first time. By switching between different users' tasks at lightning speed, the OS created the illusion that every single person had their own dedicated machine. This idea is the direct ancestor of the personal computer you are using right now. Okay, so let's fast forward.
Building on all that history, what specific services does a modern OS provide to every single application running on your machine? Well, it turns out there are 5 big ones that everything else depends on.
Now, this might look like a technical list, but it's really the story of what happens every time you use an app. The OS handles program execution. That's loading the app into memory. It manages all the I/O operations, so your keyboard and mouse just work. It runs the entire file system, so you can save your work without a second thought. And it's doing all of this while managing communications between different apps and constantly running error detection in the background. It is the essential foundation that all your software is built on.
All right, let's bring this all into the here and now. How do all these core concepts actually power the incredibly complex smartphones, laptops, and servers that we're using right this minute?
Well, today's operating systems are, unbelievably complex, and they rely on a few key design principles to get the job done. Many use what's called a microkernel architecture to keep the most critical part of the OS small and stable. They've mastered multi-threading, which lets one single app do multiple things at the same time, and with symmetric multiprocessing, they can efficiently manage multiple CPUs or cores to squeeze every last drop of performance out of the hardware.
Multi-threading is a perfect example of this in action. It is the reason why your web browser can be playing a video in one tab while another page is still loading in the background. It's one program, one single process, but it's juggling multiple independent tasks at the exact same time. It's incredible, really.
So when you look at the big picture, the story of the operating system is really just one of constant evolution. It is adapted over and over again to meet every new challenge, from single-tasking machines to interactive PCs to our modern multi-core world. Which leaves us with a really fascinating question. As our world fills up with AI, cloud computing, and the Internet of Things, what comes next? What is the next great mission for the invisible boss inside our machines?